The mind as an information processor. The irreducible principle of computational representation. The first and most dominant principle unifying the vast majority of these texts, from the foundational cognitive psychology theory books to specialized handbooks and works like Steven Pinker's How the Mind Works, is that the human mind, regardless of its biological substrate, is fundamentally a computational system that operates by creating, manipulating, and applying symbolic or sub-symbolic representations of the external world. This principle establishes the core ontology of the field. Cognition is information processing, the computational paradigm and the problem of representation. The cognitive revolution, deeply embedded in the cognitive psychology and cognitive science introductions, rests on the metaphor of the mind as software running on the brain's hardware. This perspective is the essential starting point for understanding processes like perception, memory, and reasoning. The core problem, and thus the organizing principle of cognitive psychology, is representation. How does the continuous, analog sensory world get converted into discrete, manageable, and manipulable mental units? Perception and pattern recognition. Texts on perception and cognitive methodology, e.g. Cognition Exploring the Science of the Mind, detail the initial stages of this process. The brain does not passively record the world. It actively constructs it by imposing patterns, filling in missing data, and rapidly classifying inputs. This is the first computational step, converting raw sensory data into robust, stable mental representations, e.g. object permanence, face recognition. The mind prioritizes efficiency over absolute fidelity, a foundational insight that explains common perceptual errors and cognitive biases. Rolf Dobelli's The Art of Thinking Clearly. Memory as reconstructive coding. Memory, as explored in depth, cognitive neuroscience of memory make it stick, is not a recording device, but an active recursive coding system. Information is encoded, stored, and retrieved using hierarchical, association-based, or feature-based representations. The principle here is that meaning is the primary organizational algorithm. We remember things better when they are deeply processed and linked to existing representational schemas. Learning techniques like retrieval practice, Rudiger, McDaniel, and Brown, and Make It Stick, are simply applied methods for forcing the mind to strengthen the computational links and access routes to these representations. Thinking and problem solving. Higher order cognition involves the manipulation of abstract representations, concepts, rules, schemata. Problem solving, e.g., Socratic questioning for therapists and counselors, is viewed as a search through a problem space, a mentally represented map of possible actions and states, to find the optimal path to a goal state. Socratic questioning, a core tool in CBT, is simply a technique to help the client identify and restructure the faulty or inflexible cognitive schemata, internal representations, that are generating emotional distress. Beck's framework. The efficiency, imperative, and the adaptive shortcut, a crucial second layer to the information processor principle, is the efficiency imperative. The brain is computationally limited, e.g., attention capacity, processing speed, forcing the mind to employ shortcuts, heuristics, and biases. This is the central theme of The Art of Thinking Clearly and the implied mechanics in books like The Elephant in the Brain, discussing hidden motives. Habits and automaticity. The formation of habits, the power of habit, is the ultimate expression of computational efficiency. The mind offloads complex repetitive sequences into basal ganglia loops to free up conscious cognitive resources. A habit loop, cue routine reward, is a compressed, automatic program that bypasses the resource-intensive prefrontal cortex. Cognitive biases. Biases are not errors. They are adaptive heuristics that minimize cognitive effort while yielding satisfactory, good enough answers in real time. This includes concepts like availability heuristic, anchoring, and confirmation bias. The failure to recognize these computational shortcuts leads to irrational decision-making, which is why awareness of them is essential in both performance, psychology, and clinical therapy. In synthesis, the mind as an information processor principle dictates that human experience, from the simplest perception to the most complex plan, is mediated by the creation, manipulation, and application of internal representations. Psychology's task, from the perspective of this principle, is to map the algorithms, measure the efficiency constraints, and design interventions, like CBT, that restructure faulty or inflexible internal programs, representations, to improve behavioral output. The underlying assumption is that to understand the mind is to understand its code, the embodiment of cognition and the brain-behavior nexus, the irreducible principle of physicality and situatedness. The second core principle, driven by the cognitive neuroscience texts, the Oxford Handbooks, and contemporary theories like the extended mind, asserts that cognition is not a purely abstract, disembodied process, but is physically enacted, structurally constrained, and functionally situated within the body and its environment. This principle challenges the strict software-hardware analogy by demanding that the computational mind must always be understood as an embodied system with specific anatomical and evolutionary constraints. The brain as the necessary and sufficient substrate. The foundational text of cognitive neuroscience, the Oxford Handbook of Cognitive Neuroscience, Cognitive Neuroscience, the biology of the mind, establish the brain-behavior nexus. Every mental function, from memory to emotion, is reducible to the activity of specific neural circuits. This moves the study of cognition from the realm of philosophical abstraction to empirical, measurable biology, functional localization and modularity. The principle holds that cognitive functions are, to some extent, localized to specific brain regions, e.g. Broca's area for speech production, hippocampus for memory formation. Evidence from brain lesions, cognitive changes in behavioral control, and clinical neuropsychology is crucial here. Damage to a specific region leads to predictable, systematic loss of a cognitive function, proving the physical constraint. The eye, brain is modular, composed of specialized subsystems which allows for efficient parallel processing, but also creates distinct points of failure. The evolutionary constraint, origin of mind. Geary's Origin of Mind and Related Evolutionary. Texts situate cognition within the context of adaptive advantage. Cognitive modules, like core knowledge of physics and number, explored by Spelke in What Babies Know, evolved to solve specific, recurring ecological problems. This implies that the architecture of human cognition is not arbitrary, but bears the indelible mark of its evolutionary history, prioritizing social interaction, resource competition, and environmental navigation. Cognition as embodied and extended action, moving beyond the brain itself, contemporary neuroscience asserts that cognition is fundamentally embodied and extended. Embodied cognition, texts on performance psychology. Perception, action, cognition, and emotion are key to this link. Cognition is deeply intertwined with action and perception in a continuous loop. We do not perceive a cup and then decide to grab it. Our perception of the cup's graspability is part of its cognitive representation. The brain's primary purpose is not contemplation, but motor control, to guide the body successfully through the environment. Therefore, cognitive processing is optimized for the speed and execution of motor commands. The principle is that the body is a critical computational tool, not merely an output device. The Extended Mind, the Oxford Handbook of 4E Cognition, Embodied, Inactive, Extended, Embedded, and books like The Extended Mind push this boundary further. Our cognitive processes often outsource memory, calculation, and planning to tools, notebooks, computers, or environments. Moonwalking with Einstein, make it stick. Andy Clark's The Experience Machine suggests our minds are prediction engines, constantly interacting with and shaping reality, making the environment an inseparable part of the cognitive loop. The principle is that the boundaries of the cognitive system extend beyond the skull. The mind is situated in the world, the neurophysical basis of adaptation. The most hopeful and practically significant aspect of this principle is neuroplasticity. Neuroplasticity, your brain's superpower. This concept asserts that the physical substrate of cognition is not static, experience-dependent change. The brain constantly rewires itself based on experience, learning, and environmental demands. This neuroplasticity is the biological mechanism underlying the success of learning and cognitive interventions. Every act of deliberate focus, every repetition of a new skill, e.g., the skills learned in Learn Like a Pro, literally alters the synaptic strength and sometimes the anatomical structure of the brain, mental force, and behavioral control. Jeffrey M. Schwartz's The Mind and the Brain highlights the powerful and counterintuitive ability of mental force, conscious attention, and focused thought to drive plastic change, particularly in overcoming disorders like OCD. This demonstrates the recursive loop between the abstract cognitive program, focused intent, and the physical substrate, neural circuits, proving that the mind can, within constraints, re-engineer its own hardware. In synthesis, the embodiment of cognition principle mandates that any complete understanding of the mind must be grounded in its physics. The mind is a product of its brain, optimized for action and survival, and is engaged in a continuous transactional relationship with the body and the environment. This means psychological and cognitive interventions must ultimately translate into physical change, the restructuring of neural connections, to achieve lasting behavioral and functional improvement. The dynamic architecture of adaptive intelligence, the irreducible principle of self-correction and optimization. The final principle unites the fields of learning, intelligence, clinical intervention, and habit formation, asserting that the primary, teleological drive of the cognitive system is self-correction toward optimization. Specifically, the iterative reduction of error and the refinement of complex functional behaviors to achieve higher levels of adaptive intelligence. This principle moves beyond the structure of the mind, principles 1 and 2, to its core function, the relentless pursuit of improvement and mastery. Learning as error, reduction, and prediction. Refinement, the study of learning and cognition, views knowledge. Acquisition is a continuous process of hypothesis testing and error minimization. This is the mechanism by which the cognitive system adapts. Prediction error. The latest models, including the experience machine, suggest the brain is fundamentally a prediction engine. It constantly generates predictions about the next moment, the next sensory input, or the result of the next action. Learning is the process of adjusting the underlying representations and algorithms, the code from Principle 1, when the actual input significantly deviates from the prediction error. The cognitive system is thus designed to be inherently self-correcting. The science of successful learning. Effective learning strategies, make it stick, learn like a pro, are successful because they exploit this error reduction drive. Techniques like interleaving and spaced practice work because they intentionally introduce a degree of difficulty and prediction failure, forcing the brain to recognize the error and strengthen the neural connections. Principle 2, to correct. True learning is metabolically expensive and requires the effort of correction. Intelligence as efficiency. Intelligence, the neuroscience of intelligence, is understood in part as the efficiency and speed of this error reduction and information processing system. High intelligence often correlates with the ability to process information more quickly and efficiently, reducing unnecessary cognitive effort and allowing for rapid, accurate prediction refinement. Clinical intervention as behavioral and cognitive optimization. The entire purpose of applied cognitive disciplines, especially cognitive behavioral therapy, CBT, is to provide a structured, intentional system for self-correction or optimization when automatic cognitive programs fail. CBT as optimization, CBT, Cognitive Behavior Therapy, 2nd edition, Basics and Beyond, the comprehensive clinician's guide to cognitive behavioral therapy, explicitly targets the loop of self-correction. The therapist and client use behavioral experiments to test the validity of the client's maladaptive cognitions. If I try this, I will fail. The outcome of the experiment is the prediction error that is used to modify the core cognitive schema. The entire therapeutic process is a structured, accelerated system for forcing the internal information processor to abandon faulty, non-adaptive representations in favor of realistic, adaptive ones. Socratic questioning, Codd et al., is the metacognitive optimization tool. It does not give the client a new answer. It guides the client to identify the logical errors and empirical flaws in their current, non-optimal thought process, thus leveraging the brain's inherent self-correction drive. The teleology of adaptive habit formation. The principle of self-correction toward optimization culminates in the formation of adaptive habits, which lock in refined, complex behaviors. The habit loop. Optimization. Charles Duhigg's. The power of habit illustrates how human life is governed by these automatic optimization programs. Changing a bad habit is not an act of willpower, but an act of optimization engineering. Retaining the cue and the reward, but consciously replacing the maladaptive routine, the suboptimal program, with a new, more adaptive one, the optimized program. Performance psychology utilizes this principle by focusing on deliberate practice, error analysis, and the refinement of motor and cognitive skills into smooth, efficient, expert-level habits. Mastery, e.g., moonwalking with Einstein, is simply the attainment of highly efficient, massively interconnected, and optimized representational and procedural systems that minimize cognitive load. In synthesis, the dynamic architecture of adaptive intelligence principle confirms that the study of the mind is the study of change. The cognitive system is not static. It is a Bayesian machine built to continuously update its understanding of the world by correcting its errors. From learning a new skill to overcoming anxiety through CBT, the common denominator is the iterative, purposeful act of self-correction and optimization toward a higher, more efficient and more adaptive state of being.